All right, we're gonna evaluate. Oh, why is my hand doing that? Evaluate the integral 1 minus x plus 2x squared minus x cubed over x squared plus 1 squared dx. Okay? So where do we start?
We have to divide.
We don't have to divide. Why don't we have to divide? What's the degree of our numerator?
3,
3. What's the degree of the denominator?
4.
Not quite. There's that extra x out in front, so it's the 5th power. The degree of the numerator is smaller, so we don't need to divide. Okay. After we divide, if we need to, right? What did we do next? Factor the denominator. So they've already factored the denominator a little bit for me. We need to make sure we can't factor anymore. Can I factor anymore? No, because I have that x squared plus 1, which I can't factor anymore. Okay? And so the denominator is already factored. Okay, so we're ready to set up what I think is our fractions, right? So let me come over here. 1 minus x plus 2x squared minus x cubed, x squared plus 1 squared. So what are my fractions gonna look like?
A over x.
A over x. Okay. Then I see that x squared plus 1, so what is my numerator?
Bx plus c.
Bx plus c over x squared plus 1. But it's squared in the denominator. So what's my next one going to be?
Dx plus d over x squared plus 1, all this squared.
Yes, x squared plus 1 quantity squared. Okay?
I have a question. Why is the x on a b?
Why is there? So when you have, this is a quadratic factor, and you can't factor it anymore. So whenever you have a quadratic one, the numerator is a bx plus c. It's always a degree less. So over here, this is degree 1, so you go smaller, this is a constant. Degree 2, smaller would be degree 1. Other questions? Okay. So what did we do from here? No, don't do that.
Multiply by denominator.
Multiply by that big denominator on the left-hand side. So I'm gonna write it on both sides so I remember to multiply on both sides. X squared plus 1 squared. I'm gonna multiply on the left, and then I'm also gonna multiply on the right by that same x squared plus 1 squared. Okay? So when I multiply on the left, it's going to cancel my denominator, right? So I get 1 minus x plus 2x squared minus x cubed. Now let's focus on the right-hand side. So the first term, what's going to cancel?
Probably x.
The x, okay? So I'm going to be left with,
A times.
yep, a x squared plus 1 squared. Okay, middle term, what cancels?
All one of the x squared.
One of them, so I have one left, right? So bx plus c, x squared plus 1. All right. What about the last one? Dx plus e, what do I have left? An x, exactly, So I have an x. Okay? So there were two ways really that we solved for these constants before. One was we plugged in numbers for x. The other way was we compared coefficients, right? So with us having 5 coefficients here, A, B, C, D, and E, I would go ahead and multiply everything out and compare coefficients, okay? So you're gonna start on, by foiling out this x squared plus 1, so it'll be x to the 4th plus 2x squared plus 1. I'm going to go ahead and distribute the x, so I'll get bx squared plus cx times x squared plus 1, okay? And then lastly, I'm going to distribute the x to get dx squared plus ex. Let me move that up a little so you can see. And I'm still not done. My first term, you need to distribute the a. So let's go ahead and do that. A x to the 4th plus 2ax squared plus a. The middle term, what do I need to do? Bx to the 4th plus bx squared plus cx cubed plus cx, okay? And then I still have my two terms hanging on the end, plus dx squared plus ex, okay? Now what I really care about is the coefficients of all of my terms, so I need to group all the like things together. So let's see, what about x to the 4th? Which ones do I have x to the 4th in? A and B, okay. So I got a plus b, x to the 4th. What about x cubed? C, x cubed, I only had one. What about x squared? 2a plus b plus d. What about x? Looks like I have a C and an E, okay. And then my constant, I only have one, right? A, looks like. Okay, so let me zoom out a little bit so we can see the left and the right in this messy equation. So again, we're looking on the left and comparing it with the right. These represent two polynomials that are equal. The only way two polynomials are equal is if all of their coefficients match up, right? So let's start by telling me what's the coefficient of x to the 4th on the left-hand side?
0.
0. So I'm going to set 0 equal to a plus b. My coefficient of x cubed, it's negative 1 on the left. So that's what's equal to c. My coefficient of x squared, 2. 2a plus b plus d. My x coefficient, -1, equals c plus e. And then my constant was 1 is equal to a. Okay. Oops, sorry. Let's see if I can make that scroll up without changing all that. Why do you do that? Okay. There we go. So if you notice, equation 2 and equation 5, I've already solved for two of my variables, C and A, right? From this, can you solve for another variable? Which variable could you also solve for?
B.
B in the first equation, right? So let's take it. 0 equals 1 plus B. So what's B equal to? -1.
Okay, great. What other variable can I solve for? We know C, right? From our second equation, what else? You can solve for D now, We know A and B, so let's go to our third equation, and it says 2 equals 2 times A plus B plus D. So if we solve for D, you should get 1. Okay. What haven't we solved for so far? E, yep. So you're gonna take the fourth equation, which we haven't used yet, -1 equals C, which was -1 plus E. E is 0. Okay? So these are your 5 coefficients that we need to solve for. Okay? Are there any questions about how I solve for them? Okay? All right. Okay, so we now know these coefficients, which is great, because now I go back to my original problem, and I had this integral that I wanted to solve for. So now I can replace the integral with these I can replace these with these fractions, sorry. So let's go ahead and plug in all of our fractions. So now we're looking at the integral. A was 1, so 1 over x. B was -1, so negative x. C was also -1, minus 1 over x squared plus 1. And then D was 1 and E was 0. Okay, so this is the new integral that we want to calculate. Okay, can you integrate the first term? Yeah, what do I get? ln of x, great. Okay, so ln of x, and then I'm going to break this up into 2 integrals. Plus the integral. For now, let's focus on the last integral. I want to integrate that. Do you have any ideas? Yes, exactly. Let's do substitution for that one. So let me come down here and do that for you. So I'm gonna let u be x squared plus 1 du is 1/2 x dx, or sorry, 2, I'm already dividing, 2x dx. Okay, and let's plug it in to our integral. So we can now hopefully evaluate that last integral. So I still have my first terms, ln of x, plus this thing here. And now I'll get a 1/2 the integral of 1 over u squared du. What do you get when you integrate 1 over u squared?
U to -1 over
Yes, exactly. So be very careful. I saw on some of the worksheets that we were doing, a lot of times I saw ln for this integral, which is not correct. What you want to do is think about it as u to the -2nd on our power, and then do the reverse power rule where you add 1 to the power. Okay, so I'm getting ln of x plus 1/2 u to the -1st over -1. Okay, and then replace with a u there. So I'm gonna make it a negative 1/2. And u moves to the denominator, so it's x squared plus 1. Okay? For the middle integral, this is a rational function, right? The degree is smaller in the numerator. So maybe you would try to factor the denominator. Does the denominator factor? Shaking your head no, right? So what we're gonna do, we did some of these last time, we split it up into two integrals. So I'm gonna pull out a negative out of both of them. Turn this into a minus x over x squared plus 1 dx minus the integral of 1 over x squared plus 1 dx. Okay? For that second integral now, 1 over x squared plus 1, what's the integral of that? We saw it before.
Natural log.
It's,
Natural log of the principal.
for the second one? Are you doing a substitution? Let's start with, okay. Arctangent, right? Arctangent, the derivative of arctangent is 1 over x squared plus 1. That's the tricky part, is remembering all these differences, right? So let's go ahead. So that second integral we can integrate. So I get minus arctan of x okay? And now for that other integral, you're gonna do the substitution that you wanted to do, okay? It's the same substitution we just did in the previous problem, in the previous integral. So I'm gonna do another substitution. I'm gonna let u be x squared plus 1. du is still 2x dx. Okay. So I'm getting, let me move that up. I'm getting ln of x, absolute value of x, minus, this will become 1/2, the integral of 1 over u du, arctan of x, minus one over 2 x squared plus 1. And now the integral of 1 over u is that ln of u, and that's where that term is popping up, okay? Ln, the absolute value of u, which I'm going to go ahead and replace with x squared plus 1, minus arctan of x, minus 1 over 2 x squared plus 1, and then we need to not forget the plus c. Okay? So it looks like that is our answer right here. So just be a little bit careful when you're doing substitution. You should actually go ahead and plug it in and see what you get. Try to avoid doing it in your